Water has a life-giving substance. We know this through various means of different forms of life trying to get it, trying to strive for it, and since us as humans, living beings, need water to survive without drying up, it's obviously key to a lifelike factor. There are various theories on how water actually came to Earth. One of these theories by scientists is that it came from space, where different types of comets and asteroids with water in it have billions of years ago crashed into Earth, giving us our rich supply of water, since a lot of Earth is covered in water. Since it is, the theories have come about by researching what's in the water compared to asteroids in space, and have found that it has a very similar deuterium to hydrogen ratio. Deuterium is essentially a heavier hydrogen isotope because hydrogen is a very unique chemical signature that is found in various water sources. Earth's oceans, the deuterium to hydrogen ratio is close to what is found in asteroids, which further merits and verifies the theory that asteroids one day did come to Earth and put water on this planet to help bring life. Another theory is that it both contains rocky elements and minerals from something called a solar nebula, which is a vast cloud of dust and gas remaining after the sun has formated and condensed to give us the water we have now. So, the hydrogen in Earth's oceans may not exactly represent the hydrogen throughout the planet as a whole. However, samples of hydrogen deep inside the Earth, which has it close to the boundary between the core and the mantle of Earth, have notably less deuterium, which indicates that hydrogen may have not come from asteroids, says another theory, but have actually the noble gases of helium and neon, with the isotopic signatures inherited from the solar nebula, which is the sun gas condensing and forming water, because that's been found in Earth's mantle. So, to explain these differences, research is very much needed to develop a new theoretical model of Earth's formation to answer the questions that they've been having. So, according to the model, Earth was the largest of many planetary embryos, which were called protoplanets. Planetary embryos and protoplanets are small planets that, well, not exactly planets, but small enough asteroids or big hunks of rock to merit its own type to eventually become a planet it has the potential to in the early solar system of our galaxy. So, the surface of the very young Earth was initially an ocean of magma, not water, where hydrogen and noble gases from the solar nebula were very much drawn to the planetary embryo of Earth. This formed the first atmosphere, which was called nebular hydrogen, which contains notably less deuterium and is lighter than asteroidal hydrogen, because that dissolved into molten iron of the magma ocean. Hydrogen was then drawn to the center of Earth, which this process is called isotopic fractionation. Hydrogen was delivered to the core and was attracted to its iron because while much of the heavier isotope, deuterium, remained in the magma, which eventually cooled from the mantle. Impacts from the smaller planetary embryos and other similar objects, due to these having impacts and crashing into this early magma-formed Earth, attracting these heavier elements, continued to add additional water and mass until Earth reached the size we know today, if not a little bit smaller or bigger, depending on different magma events forming new lands and whatnot. Due to this, the end result was that Earth had these noble gases trapped deep in its interior with a lower deuterium to hydrogen ratio that was also trapped in its core. More of this, since this happened in the earlier form of Earth, in its protoplanet stage when it was just nothing but magma, has way more in its core since it was attracted then than in its mantle and oceans. Because most of Earth's water did come from asteroids in this theory, but some also came from the solar nebula of the planet and its gases forming. So, you might ask, what about the comets, since they have so much water and ice in them? Because comets contain a lot of ices, and there's a theory that some of them could have supplied water, but there's also another way to kind of think about the sources of water in the formative ways of early solar system, because water is hydrogen plus oxygen, and oxygen is super abundant in waters and ices, and any source of hydrogen could have served as the true origin of Earth's water and oceans. Comets also have a higher deuterium to hydrogen ratio, so this theory kind of falls off there because that's not a good source for Earth's water, because the deuterium to hydrogen ratio of hydrogen gas in the solar nebula was way too low to have supplied water on Earth. But asteroids are much better match along with the solar nebula due to their deuterium to hydrogen ratio, and because it's way more higher than the comets. And something to further support this theory is that within the past few years we have found a asteroid out there which actually contains water or something very close and similar to water that's found on Earth, which contains different little rocky substances and minerals that can be same found here on Earth's oceans. So the new results have implications for rocky exoplanets orbiting other stars. So these exoplanets have been discovered because these have also a greater chance to have water on them, like liquid water, not even solid ice water, which increases the chances of these planets being habitable. So there's also a chance that these could have been the sources for Earth's water due to them having liquid water as well, which could have impacted Earth at some point. I hope you all have a nice day. Thank you for watching my speech, and I hope you all learned something today.